Now let's turn to differentials. Remember how we use the notation dy by dx to take the derivative of function y with respect to x. Definition. Let y be equal to f of x and make sure that it's a differentiable function to begin with. Then the differential dx is an independent variable and the differential dy is equal to f prime of x dx. And if you look at this, dy depends on the derivative of x times dx. Here's an example from the book where we are asked to find dy. And what is the definition? Dy is just the derivative multiplied by dx. So dy in letter A would be equal to, first let's take the derivative, which is 5x to the fourth plus 37, and then multiplied by dx. Now, in letter B, we are to find dy at a given value when x is equal to 1 and dx is equal to 0.2. So that's just 5 times 1 to the fourth plus 37 times 0.2. And all of that will give us 8.4. Now what does these all mean graphically? Let's look at any generic function, and here our actual curve is the blue curve, and we have already learned that a linearized version is the line tangent to the curve at our center of approximation at x equal to a. Now, geometrically, what the differential dy is, it is the change in the linearization of f of x by an amount of delta x. And notice here that the movement from a to a plus delta x is this amount, right? So that's why dx is equal to delta x. Now, but what about delta y? Delta y would be the difference from here to here. So that's that amount. And dy would be the difference between this point and this point. That means it's the change in the linearization of f. So if dx is small, that means the change from this point to this point when it gets closer and closer to a, then that means that the linearization is very, very close to our curve. Let's look at the derivatives in differential form. Find dy in these following problems. Suppose we work on number 19. Number 19. So to get dy, we just differentiate the right-hand side and then we multiply by dx. So what is the derivative of 2x all over 1 plus x squared? This is just using the quotient rule. So take the square of the bottom, 1 plus x squared, whole thing squared. Now we're taking the derivative, or the expression that's on the top. We take the derivative of the top. The derivative of 2x is 2, multiplied by what is ever in the denominator, which is 1 plus x squared. Now minus 2x times the derivative of what's in the denominator, which is 2x. And then all of this whole thing that we differentiated will be multiplied by dx. So now that's just equal to 2 plus 2x squared minus 4x squared, and whole thing divided by 1 plus x squared, whole thing squared, dx. And that's just equal to, simplifying everything, that would just be 2 minus 2x squared over 1 plus x squared, whole thing squared, dx. Okay, now we can still use the differential even in an implicitly defined function. So let's find dy in number 21. So we take the derivative of 2y, and then also we take the derivative xy, and then we take the derivative x multiplied by dx. So let's do that. We have 2 times 3 halves, and then we multiply y raised to the 3 halves minus 1 would be 1 half dy plus, now let's differentiate the product xy. So the differential of x is dx multiplied by y plus, now we take x times the differential of y minus dx equal to 0. So that cancels out, and we just factor out the dy, and then the rest will be moved to the right hand side. So what we have is dy multiplied by y to the 1 half plus x, and then if we move these other terms to the right hand side, what we'll have is dx minus dxy. And so this is equal to dx times 1 minus y. So our dy will be equal to 1 minus y whole thing when we divide everything by divided by y to the 1 half plus x multiplied by dx. Okay, few more problems. We have to find dy, differentiate the right hand side, and multiply by dx. So what is the derivative of secant? It's secant times tangent of whatever the argument is. So let's multiply secant of x squared minus 1 times tangent of x squared minus 1. And then we're not done yet because we take the derivative of the argument of secant and tangent, and that's 2x multiplied by dx. So if we want to put this term in the front, the final answer will just be 2x times secant of x squared minus 1 times the tangent of x squared minus 1 whole thing multiplied by dx. Alright.